Simultaneous linear equations, written and presented by me, Sean LeGuy. Here's the legal stuff. Let's draw a couple of straight lines. I start with $2 in my pocket and I earn $5 an hour. So at zero time I have $2 and then I earn $5 in 1 hour. So after 1 hour I have that amount of money and I'll draw a straight line on that. That's a linear, well, it's a line, straight line, and it has a linear equation. Of course, the standard linear equation is y equals mx plus c. M is the slope. In my case, it's 5 divided by 1, $5 every 1 hour. So the m value is 5. And c is the starting value, if you like, the intercept, and in my case that's 2. So the equation is y equals 5x plus 2. Tanya starts with $0 in her pocket and she earns $6 an hour. So she starts with $0 and she earns $6 in 1 hour. So after 1 hour she's got that amount of money. It's 2 points. I'll draw a straight line. Once again, this is a straight line, a linear equation, and it has an m value, the slope, and the slope is 6 divided by 1, $6 in 1 hour. The intercept, the starting point, is where it crosses the y-axis, and that was $0 in Tanya's case. So the equation is y equals 6x plus 0. Now, I'll probably drop that 0 later because you don't really need it, but I'll keep it there for now. What I want to do is to solve these two equations, which means find where they cross. To do that, there's two ways. The first way is just to look at the graph. And just looking at the graph, it looks like they cross there, which looks to be 2 hours, and looks like that would be at $12. So 2 and 12. So that's the first way. Just graph them and see where they cross. Another way is by equations. And what we say is, there's my equation, and this is Tanya's equation. At the point where they cross, they both have the same x, and they both have the same y. Now, what that means is that my y is the same as Tanya's y. Y equals y. Well, that's not very useful. But if that part of the equation equals, then the other part must equal as well. So 5x plus 2, that's from my equation, must equal 6x from Tanya's equation. And they both have the same x, so x is the same in both cases. So rearranging that then, I get 2 equals 6x minus 5x, and x equals 2. To find the y coordinate at x equals 2, I'll choose one of the equations. I'll just choose Tanya's one. So there we've got x equals 2, that's the crossing point. Now I'm going to find the y coordinate, and I'm going to get Tanya's equation, and I'm going to plumb x equals 2 into it. And shove in x equals 2 into Tanya's equation, I get y equals 6 times 2 plus 0, y equals 12. So the crossing point is at 2, 12. So that's the mathematical way of finding the point where they cross. In summary, solving simultaneous equations, there are two methods. The first method is to draw the graphs, and just from the graph read off the x and the y where they cross. The second method is to make one equation equal to the other and find the x, then put the x value into one of the original equations to find the y. So there's the equations, put them together, gives me an x of 2 using Tanya's equation, and I get a y of 12. So solving simultaneous equations, there are two methods. Method 1, draw the graph. Method 2, make one equation equal to the other, find the x, put the x into one of the original equations to find the y. And that's solving simultaneous linear equations.